All right. So, y'all, these problems here, the same type of thing, still dealing with the ratio and proportions, okay? So the first problem that I got here on this page says, look, it takes Kim 26 minutes to type and spell check 14 pages of manuscript. Find how long it would take her to type and spell check 63 pages. Okay, so y'all, when I'm setting up these problems, I'm always going to have one fraction equals to another one. Okay, 26 minutes. So I'm going to go 26 minutes for how many pages? 14 pages, right? Look, y'all, when I look at the second part, find how long. I'm looking for the number of minutes. Well, if the number of minutes was up here on the top, I'm going to put the number of minutes up here on the top. I don't know what it is because it's asked me to find that. To do how many pages? So look, if we had 14 pages there, now we're going to put 63 pages here, right? Okay, so look, y'all, I'm going to cross multiply. I'm going to say 14 times x is a 14x, right? I'm going to take my calculator. We all got a calculator now. So let's do 26 times 63, whatever that is, 1638. And then we'll divide everything, y'all, by 14. And so let me divide this by 14. And 117 minutes? And there's my answer right there, right? Y'all, what I'm hoping that you find is, these are word problems, right? Guys, in my opinion, and again, I told you I taught my first class here in 99. I actually taught at UTPA in 1997. But in the time that I've been doing this, my experience is students find these to be the easiest of the word problems to do. Not that every word problem is going to be easy. I'm not going to lie to you because I know some of them aren't. But most people tend to pick up on these. Okay, so I'm hoping you're getting that experience. If you're not, tell me and I'll help. I want to make sure that we're good. Okay, so let's take a look at the next one. Very similar problem, right? It takes Mark 20 minutes. Okay, so Mark's going to take 20 minutes to type 6 pages. Okay. Find how many pages he can type and spell check in 0.5 hours. Y'all, one thing I want to mention here. The first part said 20 minutes. Now it's telling me 0.5 hours. I need to have that in minutes también, right? So look, what is 0.5? That's half an hour, right? And half an hour would be 30 minutes. Excellent, right? So look, y'all, 30 minutes. And we want to know how many pages, so I'm going to put X pages down here, okay? Again, y'all, we're going to cross multiply. 6 times 30, that's going to give me 180. 20 times X is going to give me a 20X. We'll divide everything here by 20, y'all. And 2 goes into 18, what, 9 times? And look, there's my answer, okay? Okay. Let's keep moving along here. It says a punch recipe calls for mixing 3 parts of cranberry juice with 7 parts of strawberry juice. Find how much cranberry juice should be mixed with 63 ounces of strawberry juice. Okay, 3 parts cranberry. So the first number on the top is cranberry. The second number, y'all, is going to be for strawberry, right? Now, when I read this part of the sentence, find how much, what? Cranberry. So we don't know how much cranberry juice we're going to have, but we're going to have how much of strawberry? 63, right? Good. Okay, again, y'all, I'm going to cross multiply. 7 times X is a 7X. 3 times 63 should be something like 189. Excellent. Let's divide everything here by 7. And are you guys coming up with 27? Is that one of my choices? There it is, right? Again, how I set up the first fraction, y'all, is going to tell me how to set up the second one, okay? Bless you. So guys, and one thing I want to mention about this particular problem, when it says like 3 parts cranberry juice, 7 parts of strawberry juice, And then the next one says ounces. And sometimes people say like, hey, you know, if it's parts, is that the same thing as ounces? It could have been ounces, it could have been gallons. It doesn't really matter. They're just telling you, however, whatever unit you're using, you're going to have three of them. So you could get 3 cups of cranberry juice, 7 cups of strawberry juice. You could have 3 gallons cranberry juice, 7 gallons strawberry juice. Does that make sense? So if anybody happens to go into, like, say, culinary arts, or you go into baking, something like that, that's how they describe everything, because they don't really care whether you're using teaspoons, cups, bucketfuls. It doesn't really make any difference. Okay. Um, yes, ma'am. Of course. So 7 should have been 117, and 8 should have been 9. You're welcome. So look, y'all, number 10 says a 3.5-ounce serving of beef has 3.8 milligrams of iron. So let's do that part first. 3.5 ounces, that's for the beef, has 3.8 milligrams, and that's how much iron is in there. Okay, the second part of the question says, how much iron is in 5 ounces of beef? Where should I put the number 5, y'all? On the top. Perfect. Because that's the number that refers to the beef. We're trying to figure out how much iron we're going to have. Okay. Again, y'all, I'm going to do the same thing here. I'm going to cross multiply. Y'all, since you have calculators, can anybody tell me what is 3.8 times 5? 19. 19, nice and pretty? Okay, and 3.5 times x we know is 3.5x. So now, if you take your calculators, y'all, and you take 19 and you divide it by 3.5, what did you come up with? 5.4 something? 428. Okay, now, again, we're rounding to 1 decimal place, right? Because it tells you right here, round to 1 decimal place. So 5.4, isn't my choice B? There you go, right? Y'all, if anybody is planning on going into allied health, what I want to mention is these problems we're doing here. So if you want to go into nursing, one of the things y'all do in nursing is called dosage calculations, right? So if I had a particular illness, right? And I'm sorry, what's your name? Perla. If Perla had the same illness, right? They're going to give us the same medication. They're going to give Perla more medicine or less medicine based on how big each of us are. She's going to get much less than me, right? So if you try to give Perla the same amount of medicine you gave me, you're going to overdose her, right? If you try to give me the same dosage you gave Perla, I'm never going to get better, right? So a lot of times dosage calculations, y'all, are based on body weight, right? Mass, that kind of thing. So look, let's take a look at this problem here. The adult daily dosage for certain medicine is 80 milligrams for every 25 pounds of body weight. I'm going to stop right there because I'm going to set up my first fraction. We're going to say 80 milligrams for 25 pounds, right? Okay. If a patient weighs how much? Where should I put that number? There you go. Guys, I hope that once you see this, you say, you know what? Maybe I was thinking about going to nursing. I know I can do dosage calculations because this is exactly how you do them, right? Not right. Well, it's more than that. But what I'm saying is that this is what I'm saying is that you could do a dosage calculation if you needed to, right? We're trying to figure out how many milligrams we're going to need. Oh, I agree. Nursing is much more than that, but at least you could do this part. Oh, I know. It's a lot of stuff. 80 times what? 150? Oops. Let's see. 12,000. And then we divide it by 25 and 480 or 3. Which one is it? 480? 480. That's not one of my choices though. No. Ah, there we go. Okay, here we go. I didn't even finish reading the problem. If he is to receive a dose of this medicine every 3 hours, find how much medicine he should receive in each dose. Okay. Let's see. Well, let's see. He's going to get a dose of this every 3 hours. Okay. I want you to notice something here, y'all. Look what it says. The adult what? Daily. Okay. So this is how much he's supposed to get in what? In one day, right? That's how much he's supposed to get in one day. Okay. Now let's figure this thing. Let's figure out the next part. He needs to, this is how much he's supposed to get in one day. We want to know if we're going to give him that 480 milligrams in a full day, but we're going to split it up into here's a little bit 3 hours, here's a little bit 3 hours, here's a little bit 3 hours, right? What we want to figure out is how many 3 hour increments are there in a day? So let's think about it this way. Would you guys agree that one day is the same thing as 24 hours, right? Okay, so if we're going to do this every 3 hours, we want to know how many increments are we going to give him? We're going to give him what? 8 increments? So we need to divide this number by how much? By 8, right? So look, let's come back here. Let's take that number. Let's divide it by 8. And we're coming up with how much? 60 milligrams. Is that one of my choices? There it is, right? Okay, now guys, I want to make sure that we understand why did we divide it by 8 and not by 3? Because they were going to give it to him every 3 hours. Now, if they were going to give it to him every 8 hours, then we would divide by what? By 3. Does that make sense? Okay, good. Okay, so look, guys, let's go through 6.7. It's going to be a short section. Then we'll take our like 15-minute break and we'll come back and do another 3. Okay. Y'all, again, I have it titled 6.7 because a few years back we used a different book. We covered this topic. That was just a section that it came out of, okay? But it's not important. Like, oh, why is there 6.7? Why is there 5.2? That's not really the important part. Y'all, these problems here, we're going to do these just like we did the ratio and proportion problems, okay? So look, this is the first thing I'm going to do. I'm going to set up a fraction. One fraction equals to another. Okay, there's 2 ways I can go about doing this. I'm going to look at the first triangle, okay? And I'm going to say, look, 3 is to 6. So 3 is to 6. As if I look at this triangle, wouldn't I say x is to what? 9. There you go. Okay, that's one way you can look at it. Okay. Another way you can look at it is, do y'all agree that this side here is kind of the smaller side? Okay, so 3 is the smaller side and 6 is the longer side. So look, 3 on the top, smaller side, 6 on the bottom, longer side. Isn't x the smaller side? And isn't 9 the longer side? And we're kind of doing the same sort of thing, right? This is all we're going to do. Okay, we're going to just try to find what's that value. Let's cross multiply. 6 times x is what's 3 times 9? 27. If we were to divide everything by 6, 4.5. And now we're done. Okay. So what I really want to emphasize here, y'all, similar triangles are ratio and proportion problems too. Okay, they're the same types of problems we just got finished doing right now. Let me ask you a question. Based on the way we did that problem, if I were to write one fraction equals another one, how would I set up my first fraction? How would 12 on the top? And then what? 18 over here? What would I put over here? 4 and? There you go, right? N or X, whatever letter they give me, right? Okay, so look, let's cross multiply. 12 times N, I know is a 12N. Anybody know what 18 times 4 is? 72? Okay, so we're going to divide both sides by 12. What do we get for N? 6, right? So that side right there is 6. This side up here, y'all, was 4.5. Okay. All right. Let's take a look at this next problem here. Look what it says, y'all. The tallest tree standing today is a redwood located in Humboldt Redwoods State Park near Ukiah, California. Given the following diagram, approximate its height. Okay, so look, they give me a picture. Here's the tree. There's a shadow that's being cast. The shadow is 73 feet long. Then we have, it looks like a flagpole that's 10 feet tall with a shadow that's how long? 2. Okay, so look, let's do the same thing. One fraction equals another one. Look, y'all, they're already saying, well, we don't know how tall the tree is, so we're going to call that X. What should I put on the bottom? 73. Then over here, what should I put? 10 and? Perfect. Okay, so let's go ahead and cross multiply. 2x equals 73 times 10 is 730. Let's divide it by 2. Is that 365? How tall is that tree? Is that pretty tall? Yeah, you know why? It's the tallest tree, right? There you go, right? So it's the tallest tree, right? That's a big tree, right? 365 feet tall. Okay, so look, y'all, we got 2 more problems to do, and then let's take a little break. Okay, so let's take a look here, y'all. It says the triangles are similar. Use them to find the length of the side X. Okay, so we're trying to find this bottom piece right here. Okay, so guys, the way we set up the first fraction is going to tell me how I'm going to set up the second one. Okay, so suppose I was looking at the small triangle, the one on the inside. Could I say 3 is to 5? So 3 is to 5 here. If I did that, then what numbers should I use for the big one? 6 is to what? There we go, right? Now, could we have done 4 to 5 and 8 to x? Yeah, we could have done that too, right? We just had choices here. Okay, so look, let's cross multiply. 3 times x is a 3x. 5 times 6 is a 30. And if we divide everything by 3, y'all agree we get 10? And look, there it is. Okay, so y'all, this problem here, this last problem here, similar to the one we did with the tree. The only difference is there's no picture. Okay, so look what it says. We have a flagpole, and the shadow is how long? Okay, so look, here's my flagpole. I'm going to draw my flagpole itself. Okay, the shadow of the flagpole, y'all, is 40 feet, right? Nearby, a 5-foot tree. So look, we got a tree. It's a little tree, and that tree is only 5 feet tall. But the shadow of the tree is how long? 4 foot. Okay, so look, can I do that? Bless you. And can we do that? There you go. It's asking me, what is the height of the flagpole? I don't know. So guys, I just drew my own picture, right? Again, this is not Van Gogh, right? This is just me drawing a very simple picture. So look, would you guys agree that we could put h over 40 and then 5 over what? 5 over 4. There we go. Okay, so let's go ahead and cross multiply y'all. So h times 4 is a 4h. 40 times 5 should be something like 200. Okay, so look, y'all, we divide everything by 4. Is that 50? Okay, 50 feet. And there's my choice. And there we go. Okay, guys, let's do this. Let's take a 15-minute break. So I'm going to do this real quick. I'm going to stop recording this.